Welcome to the host nation plenary of the International Astronautical Congress of 2025. I'm Dr. Kirsten Banks. I'm a proud Wiradjuri woman and an astrophysicist, although some of you may know me as Astro Kirsten on social media. And I'm honored to be your moderator for this plenary. As an astrophysicist, I study the universe, from gravitational waves to distant galaxies, and I'm passionate about translating the latest scientific discoveries into stories that connect us all. I also share and celebrate our rich Aboriginal culture, showing how it fits into science, and not just in the past, but in the present and ongoing into the future. Culture is not ancient history. It is living, breathing, and it's evolving. It's here now, and it continues to shape how we understand the world around us. Now, we gather here today in the stunning harbour city on the land, sea, and sky country of Gadigal. I acknowledge the traditional custodians of this land, sea, and sky country in which we are, and I pay my respects to the elders, past and present, and I extend that to all of our First Nations brothers and sisters that are here from across the country and across the world as well. You might ask why we speak of Gadigal Nation here in Australia. It's because Aboriginal and Torres Strait Islanders Australia is made up of many distinct groups, each with unique cultures, languages, and laws. These are the world's oldest living cultures with deep, enduring knowledge systems and connections to country that continue to thrive today. This morning, we were given a glimpse into Australia's space history in the era of the space age, but the space history of this land extends far beyond. We are the first scientists, the first peoples to take meaning from the universe and work with it to explore and care for country, sea country, and sky country. During the Welcome to ceremony, we heard about the powerful reflections of Woomera, a place where rockets are launched in this land, Australia. But it's also a traditional tool that uses physics to launch us further. And that space exploration, just like the Woomera, it's about launching us further than ever thought possible. But we cannot do that without Indigenous perspectives. They are not just part of our past, but they're also essential to our future. I am proud to be part of that future, a future where science can walk together, where we build a space sector that is not only innovative, but inclusive and grounded in the knowledge systems that have guided this land for tens of thousands of years. Throughout this session, if you have any comments or questions, please reach out and provide them to us via the QR code on the screen. And now I'd like to invite Enrico Palermo, head of the Australian Space Agency, for his opening remarks. Enrico.
Thank you very much, Kirsten. And I also acknowledge Dr. Banks' acknowledgement of the Gadigal people on whose land, sea, and sky country we gather on today, and pay my respects to the elders, past and present. Well, good evening, everyone. I hope you've had a terrific first day, and welcome to the AEST 2025 host plenary, proudly presented by the Australian Space Agency in collaboration with the Canadian Space Agency and the New Zealand Space Agency. The plenary was shaped from Indigenous thought leaders from Australia, Canada, and New Zealand. Professor Dean Sanders, Dr. Kirsten Banks, Professor Reuben Bolt, who I note is on the Prime Minister's National Science and Technology Council, Michaela Jade, Professor Martin Nakata, Dr. Laurie Rousseau-Nepton, and David Pedanata O'Connell. I would also like to acknowledge the ISE 2025 Local Organising Committee, the Space Industry Association Australia, and the New Zealand government, who entrusted us and gifted us with this opportunity to develop this important plenary. Their support and confidence in this vision enabled us to bring this unique and I think powerful plenary. Australia is often called the lucky country, but luck alone doesn't explain the resilience, the sustainability embedded in our land. As highlighted in a report on elevating Aboriginal and Torres Strait Islander knowledge systems from the Office of the Chief Scientist, Aboriginal and Torres Strait Islander peoples are Australia's first scientists, technologists, engineers, mathematicians, systems thinkers, and more. Their knowledge, developed over more than 65,000 years, includes sophisticated understandings of astronomy, medicine, and land management. Over millennia, this knowledge has enabled adaptive, resilient, and innovative responses to extreme and isolated environments, from our hot moonscape landscapes in the Pilbara to our snowy mountains in the south. Today, we face complex challenges in space: orbital congestion, space debris, and limited universal governance frameworks. The rapid expansion of on-orbit activity raises questions of equity. Who gets access to orbital slots, to space resources? Space sustainability is not just about preserving the space environment, it's about ensuring the long-term viability of space services that underpin our economies, our communications, and our climate resilience. Ensuring the sustainable use of space is a global issue, and it demands a global response. And here in Australia, we bring to that response a legacy, this legacy of resilience and sustainability, one that stretches back tens of thousands of years. We at the Australian Space Agency have been on a journey with 5 extraordinary, respected Indigenous leaders, now joined by Canadian and New Zealand experts, to design and deliver this plenary which invites us to go beyond integration, to build Earth-sky knowledge infrastructure for co-discovery. So let's explore how ancient wisdom and modern science can come together to shape a sustainable space future and a resilient Earth. So thank you for being here, and I implore you to strap yourself in as we venture beyond integration.
Thank you, Enrico. Now we're going to hear from Professor Martin Nakata. He's been working at the cultural interface of knowledge for decades. His insights introduce us to different ways of thinking about some of the questions and possibilities we could explore, and if we're brave enough, to not just integrate Western science and Indigenous knowledge systems, but to explore what lies beyond.
For Indigenous peoples right across the world, space is not empty. It's not dark, and there is certainly no such thing as space nullius. For 65,000 years, Indigenous people have understood space as densely populated with relationships, responsibilities, and patterns that extend from horizon to horizon, not as metaphor, not as mythology, but as sophisticated intellectual assets that represent untapped resources for contemporary space science. Today, I want to share with you why achieving our conference theme, Sustainable Space and Resilient Earth, requires us to fundamentally expand how we approach space knowledge. Let me introduce you to 4 types of knowledge assets that Indigenous systems have developed over millennia. Consider this extraordinary fact. Indigenous knowledge systems contains observational data about celestial phenomena spanning thousands of years. These aren't simply stories passed down. They're compressed, encoded data sets about astronomical events, cycles, and anomalies that extend far beyond our written scientific records. When Aboriginal Australians describe the variable brightness of Betelgeuse, or when they track this 18.6-year lunar standstill cycle, they're accessing data sets that no modern observatory possesses. Think about that for a moment. Observational records that predate our telescopes by millennia. Now, raw data is powerful, but it's what you do with those observations that creates true knowledge assets. And this brings us to our second asset, Western science excels at reduction, breaking complex systems into manageable components. Indigenous knowledge systems have developed something profoundly different: frameworks for understanding relationships between seemingly disparate phenomena. They connect celestial movements with terrestrial effects through observations, as I said, spanning millennia, identifying patterns in how space weather affects animal behavior, how stellar positions correlate with climatic shifts, how lunar cycles influence geological processes. These represent correlations we haven't even thought to look for. And here's where it gets even more sophisticated. These integrated frameworks operate within completely different temporal concepts. Our third asset. Our scientific frameworks predominantly use linear time, past and present, and future, in nice, orderly sequence. Indigenous analytical methods incorporates cyclical, recursive time concepts that can identify invisible patterns to linear analysis. When Indigenous astronomers speak of the every when, where present, past, and future knowledge converge, they're using analytical frameworks that could reveal periodicities and recursions in space phenomena we're currently missing. Imagine what we might discover with these different temporal tools. And finally, these temporal frameworks are grounded in something equally sophisticated, our fourth asset. We have remarkable global telescopes and satellite networks, but Indigenous peoples have developed something unique: highly localized, precise understanding of celestial phenomena manifest at specific terrestrial locations. They've created sophisticated local calibration systems for astronomical observations worldwide. Each provides vantage points for understanding space-Earth interactions. This is precise observation at a scale and specificity we're only beginning to appreciate. Now, here's the critical point, and this is where the very opportunity lies. These knowledge assets don't exist as complete, accessible archives waiting to be downloaded. Centuries of colonialisms have fractured and displaced these systems. What I'm proposing isn't extraction of existing knowledge. It's about collaborative reconstruction and co-discovery. Think about multi-messenger astronomy. Combining gravitational waves, electronic magnetic signals, and neutrino detections reveal phenomena invisible to any single method. But here's the difference. We're not combining existing complete systems. We're reconstructing analytical capabilities that colonialism made invisible, then exploring what becomes visible when these reconstructed frameworks combine with contemporary space science. This isn't about adding perspectives to your existing work. It's about exploring entirely new analytical capabilities through a collaborative reconstruction process. Kirsten.
Thank you, Martin. Progress doesn't come from staying in our comfort zones, and you've given us much to consider as we shift focus to some practical applications of the concepts you've outlined. Our first case study takes us to Canada, where we'll explore a rich tapestry of multidisciplinary and multi-generational insights. We're joined by Laurie Rousseau-Neptune, an assistant professor at the Department of Astronomy and Astrophysics at the University of Toronto. Laurie brings us a unique perspective that bridges cutting-edge astrophysics and Indigenous knowledge systems, offering a powerful example of how science and culture can inform and inspire one another. Take it away, Laurie.
Kwekwe, bonsoir, good evening. Before I start, I want to thank the ancestor, and I also want to thank the stars, because without them, carry on their daily duty, we would not be here today, like literally. So I'm an assistant professor at the University of Toronto in the Dunlap Institute for Astronomy and Astrophysics. I am Innu on my dad's side and settler French-Canadian on my mom's side. I'm a member of the Pequot-Camille-Nuats First Nation, which is north of Quebec, east coast of Canada. When I graduated in astronomy about 9 years ago, my first job was resident astronomer at the Canada-France-Hawaii Telescope in Hawaii. It was my dream job. I studied there star formation. It's a cycle that, for billions of years, has been happening in the universe, in which stars fabricate new elements and share them with the rest of the universe, forming new generations and eventually planetary systems and us. I also build instruments for telescopes on the ground and eventually in space, I hope. And I guess that's what defines me as an astronomer. But I quickly realized that my training was purely academic and something was missing. I didn't have any astronomical knowledge from my own community and I needed to fix that. And I think to some extent, all of us, when we graduate to any programs, we need to fix our education. And so I started reading stories and asking members of my communities, elders, about it. And I found so much. And I extended it to many other communities and also in Hawaii. And I learned about wayfinding on the ocean in Hawaii. I learned about timekeeping by the Navajo Nation, who uses constellations and stars like many others to track specific time. I learned about weather forecasting using the scintillation of stars, their appearance, their color when they cross the horizon to predict weather by the Dene community. And so much more. And all of this was related to astronomy, but also other science. It is truly multidisciplinary. And it still felt it was just like the tip of the iceberg. Like if astronomy was once something way central to all of these cultures. And this is what led me into the field of archaeoastronomy. And today, I'm going to take you on a trip on one site. I started studying North American sites, which I believe are ancient observatories. So we're going to go to Wyoming on the top of a mountain, or close to it, to the medicine wheel that is called Bighorn. And I prefer to call them, actually, Sacred Circle. This site is at 3,000-meter altitude. Ancient observatories were very different than the one we know today. They were horizon observatories, tracking the rising to the east and setting to the west of bright objects and planets. And they're defined by their methods of how to track precisely these positions. On this site, it is defined by lines of rocks and structures around the site. If you look around, you'll see on the plateau 3 areas with additional stone circles and other smaller wheels with their own spoke. And I believe they're all linked to the main structure. At least they are grouped in some section here. And before I go into detail, just wanted to say that I've heard countless stories about this site. It is very far away from my own territory. We're in the territory of the Shoshone, the Blackfoot, and many others. And one story was saying that this site, when it was heavily used and when people were going often, over there was summer all year long. And believe it or not, on that image that was taken close to summer solstice, there was a lot of snow. And believe it or not, the next day there could be a snowstorm. And so I knew just by this story that the site had to be very old, pushing us back to a time when it was much warmer on the summit of that mountain. And with 28 spokes and so many structures, I had the hope that my science could help me maybe date the site, but even better, figure out what the astronomers were doing back there. And so, in order to do that, you need modern tools to precisely assess which stars and planets were rising and when. And so you need data elevation model. Those are helping an astronomer to define very precisely the horizon line, knowing all of the mountains and plains that are surrounding the site over hundreds of kilometers. Then you need to model the light path of the stars into the atmosphere, which act a little bit like a lens, and due to refraction, can change significantly the position of object you observe on the horizon. And then we're fortunate Nowadays, we have extremely large databases that contain the proper motions of stars, so that's their velocity in the Milky Way with respect to the sky plane. And also, it contains global motions like the precession of the equinox, which is this 26,000-year-long cycle for which the Earth rotation axis is pivoting on itself. And that changes significantly the position of stars on the horizon. And we also have visualization tools, which can be practical and send you back 5,000 years ago and see what the sky looked like back then. And so I could tell you all of what I've learned about this site, but also about myself when I studied it. But I'm not going to do that today. I'm just going to focus on one thing, though. One thing that this site taught me and that I think could teach all of you something very important. So we're going to go to the northwest on a hill very close to this main structure, where there are many smaller stone circles, 6 meters across. On that hill, it's a very special hill. It is a hill that actually crossed the horizon line about 600 meters away from the main circle. Someone standing on that hill would be sitting on the horizon line. And so, with 28 spoke, I was able to date the site. It brought us back 3,300 BC, 5,000 years ago. And all of these structures are leading to one of the spoke, one star that I was able to identify as Deneb, setting on that hill 5,000 years ago. But all of these structures had to be pushed way farther back in time. So you see here the path of Deneb in 6,000 BC, 8,000 years ago, 5,000 BC, 4,000 BC, 3,000 BC, a slow drift of a star on a hill nearby the site. But there's much more than 4 measurements up there. There's tens of them. They had purposefully designed an experiment to measure the drift of a star for thousands of years, measuring the precession of the equinox, this 26,000-year-long cycle. When I saw that, I realized that they had to have been building the site there for that very purpose, or at least that they had it in mind. The main wheel is located there to have access to that hill to make those very measurements. The builders, when they built it, they probably didn't even got the fruit of their labor. They didn't get to learn about it. They had to teach the next generation how to do these very measurements in the same way and pass along the knowledge to the next one. Up until 100 generations later, they would know about it. What they left behind is minimal. It's just a few rocks scattered on the top of a mountain. But they left behind a legacy of learning and wanting to learn about the universe. So when I think about this message that the ancients are trying to send us through this site, I think we could use a lot of it for space exploration and how we use the environmental space around the Earth. It would be unthinkable to try to clean the orbital space in 1 generation. But if we build a project and aim to clean it in 100, then that seems more accessible. And somehow, I like to think that the ancestor, if they would see us today, they'd be proud of what we can accomplish. What I do hope, though, is that in 100 generations from now, in the future, people will be looking back in time and see what decision we made. And I hope that they will be proud. And I don't know yet what they will be capable of doing in 100 generations, but I want it to happen. I want it to be possible. And I want to give them everything that they need to do the science that they want then. And so I'm sharing with you the 100 generation principle. This phrasing is based on the 700 generation principle, a principle from the Haudenosaunee community, in which every decision needs to be forecasted for 7 generations before taking it. Thank you.
Truly incredible. Thank you, Laurie. Next, we'll hear from David Pinedara O'Connell, the chair of the Te Whaki joint venture, who will share how the Te Whaki National Aerospace Centre is pioneering a bold new model for aerospace innovation, one that's deeply rooted in Indigenous values, ecological restoration, and cutting-edge technology. This approach challenges conventional paradigms and offers a vision of space exploration that is both sustainable and culturally grounded. David, the floor is yours.
Kia ora, Kirsten. Tai timu, tai pari, ngā waia maha nui, te taki haruru ki te pikau mumura o kaitorete whenua e rere ana ki a tātou e. Kei ngā mana, kei ngā reo, kei ngā mātau waka o te ao, tēnā koutou katoa. To the many distinguished authorities, the voices, the people present here from across the world, I greet you all. Picture this. You come from a culture who studied the stars long before telescopes existed, who traversed thousands of kilometres across the Pacific Ocean long before navigational use of the compass, who knew that everything in the universe is connected through whakapapa, the genealogical relationships that bind us all together. You've seen what works on your land, and your people remember how to do it. Your culture carries stories of an ancestor, Tāwhaki, who climbed to the heavens to bring knowledge and well-being back to his people. When you step into a conference of industry leaders such as this, though, you're told that this Indigenous approach is interesting, but they question whether it really belongs in serious and modern-day infrastructure decisions. At this point, you can do one of two things: argue your case, or make like that ancestor and just start climbing. Fast forward a few years, and you've established the Tāwhaki National Aerospace Centre, a joint venture between the New Zealand government and local Indigenous councils, Taumotu Runanga and Wairewa Runanga. Every action and decision is informed by Indigenous leadership, ecological expertise, and leading aerospace innovators, all dedicated to approaching aerospace in a way that protects and revitalises the surrounding environment. All located under the open skies of Kaitorete on the east coast of Te Waipounamu, New Zealand's South Island, identified as one of the best places in the world to take flight. Like that ancestor who, according to the legend of Ngaitahu, ascended to the heavens, brought back knowledge for his people and planet. This set the standard for all of our mahi, and our organisation has been named for this bold character who personifies our values and aspirations. Tāwhaki the ancestor was known for his good looks and his daring. He dared to be different and he dared to be better. And that's not always easy in a world built on established norms. When Tāwhaki set out to ascend to the heavens, he wasn't just chasing knowledge, he was challenging the status quo. He was climbing beyond what was known, guided by relationships and sheer tenacity. In many ways, Tāwhaki the organisation is doing the same. We're taking bold steps in an Indigenous-led venture in aerospace. And yes, sometimes we feel like the good-looking distant cousin who's turned up at the party and everyone's wondering what we're doing there. When Tāwhaki was announced, several of our founding team, including myself, attended an industry event that very same evening. As we sat in the room full of established aerospace professionals, the imposter syndrome was palpable. Do we belong here? Are we ready for this conversation? Will they accept the way we think? The very fact that we questioned our place in aerospace while simultaneously launching an ambitious, dual-focused initiative captures the very complexity of holding true to who we are while working within an established Western-dominated system. But here's the thing, we do belong, not just because we're here, but because our knowledge systems, our pūrākau, our whakapapa, our mātauranga are not lesser, they're not quaint, they're not historical curiosities, they're valid, rigorous, and deeply relevant to the future of Earth and space alike. Yet as aerospace develops further each year, we're discovering that many of the challenges the space industry faces, sustainability, systems thinking, long-term stewardship, are precisely what Indigenous peoples have been mastering for millennia. And as innovators and explorers know, if everyone follows the same path, you'll never unlock the potential and discovery. Tāwhaki didn't explore in a conventional way. He leapt from wave top to wave top. He adapted to challenges, and he knew how to choose the strong vine to ascend to the heavens. At Tāwhaki, we are doing the same. Our work is grounded in kaitorete, the unique stretch of whenua or land between Te Waihora, Lake Ellesmere, and the vast Pacific Ocean. It's a place of abundance, of ecological significance, of history and stories, of wide open skies. And with our Lake Te Waihora full of eels on one side, it's deeply tied to the pūrākau, where Tāwhaki meets Tuna, the eel in the highest of heavens. He tells Tuna of the bounties of Papatuanuku, our Earth Mother, and Tuna descends to live in its cool waters. This story isn't just about eels. It's about connection, about movement between realms, about the idea that knowledge flows from heavens to earth, from atua to tangata, from gods to people, and from flora and fauna to us. Recently, Dawn Aerospace completed its first flight from Tāwhaki with the rocket-powered high-altitude aircraft Aurora. This suborbital spaceplane travelled at supersonic speeds to a height of 67,000 feet to gather data and intelligence, following Tāwhaki's example of using technology to forge new relationships with celestial bodies. Likewise, our partnership with Kia Aerospace and NASA, looking to improve methods to monitor water quality, initially at Te Waihora, explores the interface of space-based intelligence with our intergenerational observation. Today, we express the knowledge that was retrieved by Tāwhaki not only through our traditional practices, but through satellites, sensors, and data. Intelligence created through observation, through perspective, through processing power that goes beyond human levels. Space technology for us becomes a means to heal, restore, and rejuvenate what defines and identifies us as tangata whenua, people of the land. The aerospace companies we support are developing technologies that could serve both interplanetary mission preparation and local ecological restoration. Sensors that might one day monitor atmospheric chemistry on other planets could also track the recovery of our waterways, measure how to restore native plantings affected by local weather patterns, and document the return of native birds to rejuvenated landscapes. This is what Indigenous futurism looks like in practice. We're not choosing between preserving traditional culture and advancing into space. We're creating infrastructure where space technology can strengthen connections to place, to ancestors, to the natural world that has sustained us for generations. Indigenous peoples represent less than 5% of the global population, yet we protect 80% of the world's biodiversity. This isn't coincidence. It's the result of knowledge systems that understand relationship, reciprocity, and long-term thinking. As we venture into space, as we contemplate becoming a multiplanetary species, shouldn't we be centering precisely on those types of knowledge frameworks? This is our challenge and our opportunity. How do we ensure that our expansion into space strengthens rather than severs our connections to each other, to our home planet, and to the relationships that make us human? The aerospace industry has a choice. We can continue replicating the same extractive, capitalist, hierarchical models that have created the current environmental and humanity crises, or we can embrace Indigenous knowledge systems that offer pathways to sustainable, relationship-centred approaches to space exploration. Our integration of environmental knowledge with aerospace facilities aims to enable innovations that purely Western approaches might miss. So what does it mean to ascend to the heavens? It means daring to be different. It means imagining the impossible. It means choosing the strongest vine. It means gathering knowledge with humility and purpose. It means recognizing that Indigenous knowledge is not a relic, it's a roadmap. It means understanding that space is not a frontier to be conquered, but a realm to be engaged with ethically, rationally, and respectfully. It means knowing that our whenua, our ancestral home, is not separate from the space technology. It's the reason for it, the purpose. This is Tāwhaki's challenge to you. Climb higher, but never forget while you're climbing. Gather knowledge from every relationship, every connection, every kinship tie between earth and sky. And when you reach the heavens, remember that the real test isn't whether you can stay there, it's whether you can bring back wisdom that serves all life. Tāwhaki is climbing again. Who will join us in the ascent? Nō reira, tēnā koutou, tēnā koutou, tēnā tātou katoa.
Thank you, David. A truly powerful sentiment. Now, finally, we turn to Australia to explore the theme, Walking with Fire, Lightning, and Legacy, where we'll uncover powerful insights for building a sustainable space future and a resilient Earth. We are joined by Professor Ruben Bolt, Deputy Vice-Chancellor of Indigenous Strategy and Services at the University of Sydney, who will share how Indigenous knowledge systems, rooted in deep connection to country and guided by generations of wisdom, can inform and transform our approach to science, sustainability, and innovation. Thank you, Ruben.
Thank you, Kirsten. Good evening, everyone. I'm very honoured and privileged to be able to work at the intersection of Indigenous knowledge and future-facing innovation. But before I begin, I want you to think about something that I'm about to say. I want you to hear it, but not only hear it, I want you to listen to it. Listen to what I'm about to say. And what I'm about to say is this. Indigenous knowledge is an asset to the world and a gift to humanity. Today I want to share with you 3 Australian case studies that beautifully and succinctly demonstrate how Indigenous knowledge systems and Western science has come together. Not in competition or surrounded with tensions and controversy, but in collaboration and agreement to address some of the most pressing challenges of our time, including those that speak directly to sustainable space and resilient Earth. These 3 exemplars are Painting with Fire, Rainstick, and David Yunapon's weaving of ancient knowledge and modern innovation. Let's begin with fire, not as destruction, but as creation. For over 65,000 years, First Nations peoples have used fire as a way of reading and caring for country. In Northern Australia,
Cultural burning is a practice of lighting small, cool fires in mosaic patterns. These burns are done with precision, at the right time, in the right places, and for the right reasons. They protect sacred sites, regenerate native plants, support animal habitats, and reduce the risk of catastrophic bushfires. As Uncle Victor Stephenson, a Tagalaka man, says, "We don't fight fire with fire, we walk with it." But this is not just land management. It's law, it's ceremony, and it's intergenerational knowledge transfer, providing qualitative context for a sophisticated, holistic knowledge system. And what is critically important is that Western science is now beginning to catch up. Research shows that cultural burning improves soil health, reduces fuel loads, and supports biodiversity. Satellite imagery confirms that areas managed with cultural fires are more resilient to climate extremes. Fire information derived from Earth observation satellites provided through the North Australian Fire Information, or NAFI, web service to Indigenous communities for the last 22 years has informed Indigenous-led fire programs that have been integrated into carbon credit schemes, reducing emissions and generating income for communities. The result is fire reduction on a globally significant scale. Initiatives like the Fire Sticks Alliance and the Savannah Burning Program are using technologies like projection-augmented 3D landscape models to co-design fire strategies with traditional owners, ecologists, and land managers. This is significant, and that's because Indigenous knowledge is not just historical, it's dynamic, adaptive, and essential to our future. And when we listen, learn, and collaborate, we unlock solutions that are holistic, contextualised, and deeply respectful of country. There are windows and doors of opportunity for Indigenous knowledge systems to add another dimension through which to explore our ways of knowing, being, and doing. Imagine how these principles could be applied to the complex challenges of sustainability in space, where resilience, regeneration, and respectful stewardship are just as critical. Now let's turn to lightning. In far north Queensland, an Indigenous biotech startup called Rainstick is transforming agricultural using lightning and lore, L-O-R-E. Led by Darryl Lyons, a Mayawali man and third-generation farmer, and technologist Mick Black, Rainstick blends thousands of years of Indigenous knowledge with cutting-edge science. The Mayawali people traditionally used a ceremonial tool called the chagara, or a lightning stick, to influence thunderstorms and support plant growth. After storms, they observed stronger plants, flourishing fungi, and rejuvenated soil. Rainstick honours this tradition by mimicking lightning's natural effects to stimulate growth, without chemicals. Western science calls this electroculture, using electric fields to influence biological systems. Rainstick's technology applies variable electrical fields to seeds, enhancing root development, shoot growth, and drought resilience. They've partnered with CSIRO and universities to validate the effects, showing improvements in germination, reduced pesticide reliance, and boosted microbial health. And here's where it gets exciting. Rainstick's innovation isn't just for Earth. These principles are being explored for space farming, where resources are limited and sustainability is critical. Their predictive models and bioelectric treatments could support plant growth in space stations or lunar habitats. Rainstick shows us what's possible when Indigenous knowledge systems are respected and interwoven with Western science. It's not just about growing better crops, it's about growing better futures. Finally, let's honour a visionary, David Unaipon. Born in 1872, Unaipon was a Ngarrindjeri man, inventor, writer and thinker. He held 19 provisional patents, many inspired by his cultural knowledge and spiritual connection to the natural world. His inventions included a rotary shearing machine, a centrifugal motor, helicopter designs inspired by the boomerang, anti-gravity and perpetual motion research, and contributions to ballistics. These were more than just mechanical achievements. They represented his ability to innovate and intertwine Western scientific frameworks with Indigenous knowledge systems. Yet despite his brilliance, UNAPON faced systematic barriers, limited access to education, no institutional support, and racism. At that time, Australia failed to fully embrace his contributions and inadvertently squandered a chance to lean in early to a new, novel approach. What a missed opportunity. But today, his story is being reclaimed as a symbol of what's possible when Indigenous knowledge systems are valued. In my role as a scientific expert member of the National Science and Technology Council, co-chaired by the Prime Minister and the Minister for Science and Industry, I have played a key role in delivering the refreshed National Science and Research priorities. One of those priorities is to elevate Aboriginal and Torres Strait Islander knowledge systems. Imagine if this priority was in existence at that time, 1872, how that might have shaped Australia's innovation pathway, its infrastructure development, and global scientific standing. In any event, UNAPON's life and legacy shows us that the weaving of Indigenous knowledge and Western science is not only possible, but it's powerful. So what does this teach us? That sustainable innovation is not new. In fact, it's how our cultures have survived for millennia and will continue to thrive. That Indigenous knowledge systems are not static. They are dynamic, adaptive, and future-facing. And that true innovation happens in partnership. When we walk together, listen deeply together, we in fact co-create solutions together. To care for our land, sea and sky country, which includes space, we can learn more when walking together and honouring those who have cared for country the longest. Let's honour this knowledge, not just with a pat on the back, but with action. Together we can shape a more sustainable, resilient and respectful future on Earth and in space. And I leave you with what I started with. Indigenous knowledge is an asset to the world and a gift to humanity.
Thank you, Ruben, and thank you all for sharing your insights and your knowledges and your cultures with us. From these case studies, one truth really stands out, that in Indigenous knowledge systems, sustainability isn't just a goal, it's a lived reality. It's not something we strive toward, but it's something that naturally emerges from the way that we care for country as country cares for us also. These knowledge systems are grounded in reciprocity, responsibility, and deep relational understanding. When we champion Indigenous knowledge systems alongside modern science, we unlock a fuller and more balanced way of exploring and understanding our world. Together, they offer not just innovation, but enduring sustainable outcomes for Earth, for space, and for generations to come. Now, Martin, I'll come back to you with a question. How can delegates at this plenary transfer these ideas and approaches into next steps for sustainable space and resilient Earth?
Thank you, Kirsten. Consider what these cases from across the world demonstrate about the knowledge assets still in the archives. You've seen multi-generational observational data sets, astronomical records spanning thousands of years. You've witnessed non-linear temporal frameworks that track multiple simultaneous cycles, revealing periodicities our linear time models miss. You've observed place-based calibration systems that correlate celestial and terrestrial phenomena with extraordinary precision. So let me give you one more example that captures this beautifully. Take Tech in the Torres Strait Islanders. Western astronomy knows it as Acona, or Alpha Eridani, a B star rotating so rapidly it's of late 139 light years distant. But for islanders, Keck demonstrates how space makes Earth resilient. Its heliacal rising doesn't just mark linear time, it reveals when multiple cycles converge: seasonal, hydrological, ecological. And when Keck appears, it signals that Earth systems have achieved the precise balance needed for sustainable cultivation. This is sustainable space in practice. Using celestial observations to ensure Earth's agricultural system remain resilient across generations. Here's what's remarkable. Arabic astronomers call the same star Arkana, literally meaning end of the river. Different spatial locations, different cultural contexts, but the same star marking hydrological transitions. This convergence suggests that certain stellar positions and properties correlate with Earth systems, changes in ways we haven't yet mapped. Colleagues, these aren't mythologies. They're data sets encoding how space and Earth interact to create conditions for sustained life. Exactly what our conference theme demands we understand. But here's our challenge. These archives of integrated knowledge have been fractured by colonial encounters the world over, affecting their temporal and spatial frameworks time and again. The Torres Strait knowledge of Keck survives, but incompletely. We maintain the star-season correlation, but the full temporal framework, how Keck's cycles integrated with other stellar patterns, with lunar phases, with oceanic oscillations, exists, but in fragments. That spatial relationship, how Keck's position relative to landscape features guided navigation, predicted weather, indicated current patterns, are now held in the memory of just a few. Across the Pacific, knowledge systems that understood space Earth as one resilient system were systematically sutured over. Linear time imposed over cyclical frameworks. Abstract space replaced relational positioning. The very conceptual tools that encoded sustainability were dismissed as primitive. We cannot simply extract this knowledge. When Indigenous knowledges work with Keck today, they are reconstructing temporal frameworks that colonialism tried to raise. They are rebuilding a spatial concept where position isn't absolute, but relational. Where Keck exists not just 139 light years away, but in relationship to soil, to season, to the sea. This reconstruction requires Indigenous knowledge holders as lead investigators. We're not just remembering information, we're rebuilding an entire framework for understanding how sustainable space creates resilient Earth. And these frameworks, these different concepts of time and space, might be exactly what our contemporary challenges require. This is why achieving sustainable space, resilient Earth requires a fundamental shift in how we approach knowledge integration. Here's our three-phase co-discovery approach. Release the assumption that linear time is superior to cyclical time, that abstract space is more accurate than relational space, that separating space from Earth creates better understanding. Every conceptual limitation that prevents us from seeing space Earth as one system must be examined. We must unlearn the notion that sustainability means maintaining current systems rather than understanding the temporal cycles and spatial relationships that creates resilience. Once we've created space by releasing these limitations, we can begin acquiring new capabilities. We can develop competencies in different temporal frameworks. Learn how to work with time that spirals, cycles, and converges rather than simply progresses. Let's master spatial concepts where position is relational, where distance includes cultural as well as ecological dimensions. Learn to recognize how Indigenous observers track space-Earth relationships through integrated frameworks we've separated over the years into different disciplines. Now comes the important moment, where these new capabilities transform how we approach space science. We can reconstruct integrated understanding, not Western linear time versus Indigenous cyclical time, but hybrid temporal models that capture both progression and recurrence, not abstract space versus relational space, but multi-dimensional frameworks that encompasses both physical distance and systematic relationships. Relearn how Keck simultaneously exists as a B star with specific spectral properties and as a marker of Earth systems balance. Both constitute valid knowledge for resilient futures. Colleagues, this co-discovery approach isn't about cultural appreciation. It's about acquiring the conceptual tools necessary for genuinely sustainable space activities that ensure our Earth's resilience. It's about recognizing that breakthrough solutions emerge when different ways of knowing converge to reveal patterns neither could see alone. Our invitation to you all is this. Begin reconstructing the temporal and spatial frameworks of Indigenous peoples developed in your own countries for sustainable space relationships. Use the unlearn, learn, and relearn co-discovery approach. And in 1 year from now, let's come together to share what different concepts of time and space can reveal about creating resilient Earth through sustainable space. Because if one star like Keck reveals convergent understanding across continents, imagine what reconstructing humanity's full archive of space Earth knowledge might teach us about ensuring our planet's future. Enrico, the path to sustainable space resilient Earth isn't just technological. It's conceptual, encoded in frameworks we are only beginning to rediscover. And the future of space sustainability lies not in the stars alone, but the wisdom of those who have been reading them the longest. Kirsten.
Thank you, Martin. Enrico, you and the Australian Space Agency have extended us a welcomed hand to partake in this very important session of IAC 2025, the host nation plenary. We'd like to extend that hand back to you with the opportunity to respond to the call to action. Enrico.
Firstly, let me say thank you to Laurie, David, and Ruben for those thought-provoking cases. They're a gift for all of us here tonight. And I'll come to the call to the action, but as I reflect on my language and my words, I talked about the integration of modern science and ancient wisdom. And I think hopefully you all leave that this isn't about ancient wisdom. This isn't historical curiosities. And so I apologize for getting that wrong in the introduction up front. Martin clearly issued us a call to action. Thank you, Martin. The framing of the co-discovery approach really challenges us how to rethink how we generate and share knowledge, and it's a model that invites us to be open to new pathways for innovation. So with that call to action, the Australian Space Agency is ready to respond. The Australian Government's national science and research priorities implore us to elevate Aboriginal and Torres Strait Islander knowledge systems. And the Australian Government's National Agreement on Closing the Gap priority focuses us within government to transform the way we work, which lays out a clear pathway through which we can contribute to shaping a future where space science, Indigenous knowledge, and that technology can come together. To our international colleagues in the room, the call to action is to you as well. We invite you to join us in building the Earth-Sky knowledge infrastructure, one that is inclusive, resilient, and visionary. There's a lot to do that, but amongst this community of engineers, scientists, astronaut leaders, academics, we have the capability and we have the responsibility to lead. So I encourage you, I ask you to grasp this moment with courage, with clarity, and together over these 12 months, let's unlock new frontiers of discovery. Thank you.
Thank you, Enrico. What we've heard here tonight is more than a series of case studies. It's a vision for how knowledge infrastructure can be built with care, courage, and connection for sustainable space and resilient Earth. Indigenous peoples have long understood the stars, the land, and the relationships that bind them together. As we look to the future of aerospace, these knowledge systems offer us not just insight, but leadership and an opportunity to accelerate the pathways to innovation and to co-discovery of novel approaches. To honour this journey and carry its message forward, we have commissioned a message stick. I would like to call upon Dr. Alvin Harvey and our very own Professor Dean Saunders. Dr. Alvin Harvey is the moderator of the Plenary Healing Earth, Envisioning Space, Indigenous Knowledges and Partnerships for a Resilient Future. Please. Up to Dean. This message stick carries the stories, the values, and its aspirations that are shared here tonight. It's a symbol of continuity, of shared responsibility, and of the strength that comes from walking together across generations and disciplines. We pass this message stick to you to take these messages forward.
My name is Dean Sanders. I acknowledge this country and these families. I've been gifted, in our way, I've heard some extraordinary story this afternoon of science, past, present, and the challenge about how we integrate that with future. And I was reminded, as I was listening to my colleague experts here, that the gift of our knowledge isn't something to be, we haven't always shared it. I want to acknowledge that to you. We've been here for 65,000 years, we didn't just turn up yesterday. We haven't always shared that knowledge, because when it has been shared, it has been extracted, it has been misused, it's been misunderstood. Because in our way, knowledge is power. Knowledge is the currency of our cultures. It's the strength and history of our cultures. And in our way, with knowledge comes responsibility. Responsibility is a gift that we pass in the same way we pass knowledge. It's a great honour to be gifted with responsibility in our culture. As part of this community, you are all in this position of responsibility. You are the custodians of space. You are the custodians of the future of space. You have responsibility in that particular story. In our culture, we share this information. Martin and others spoke about the encoding of our knowledge. This, to some of you, may look like a message stick, a wadi, but it actually is an embodiment of science. I'm not sure if we have that particular image. But on this stick is encoded information, knowledge, volumes of it that would require several PhDs to unpack in the mere challenge of the stick, prepared by Uncle Steve, a Gubbergal man, knowledge holder of the Darug community. He prepared this stick for this. It has a name, of course, an important name that we'll be sharing. Nyaranyara, Nyaranya, Barawa, Warama, Narawayanga. And you can see there this story, this stick that carries that story of we all see you fly over Mother Country. This stick I pass to our colleagues globally because this is a global First Nations community. And we are exchanging responsibilities as the way in our culture to pass that responsibility. Alvin receives that on behalf of all of you for the process of what they will lead on Wednesday. We want to encourage the carriage of this stick, of this message stick for the future of science, for the future of space, for the future of this sector, as something gifted to the IF in perpetuity to understand the responsibility of that knowledge that we share as First Nations people with you all as part of that story. Remember, with knowledge, just like Spider-Man said, comes great responsibility. Marambu, Gapu. Thank you.
Thank you to our speakers, to our hosts, and to all of you for being part of this important conversation. May we continue to climb, connect, and imagine futures where space exploration uplifts peoples, and all places. Before we close, we invite you to take a moment to reflect on what we've heard this evening. This session is not just about gaining knowledge, it's about transformation. As agencies, as communities, and as human beings, we must embrace the journey of unlearning outdated assumptions, learning new perspectives, and relearning with humility and openness. This is how we move forward together. And the journey doesn't end here as well. At the AEST 2025, we offer countless opportunities to continue this process. By scanning the QR code on this slide, you'll be able to explore sessions that challenge, inspire, and extend your understanding throughout the rest of the Congress. And on behalf of everyone involved in this year's Host Nation Plenary, Gulbara Yamana, Ngalianergiri. Understand together, we will go together. Mandangu, thank you.